Hello दोस्तों, let us now start with our new and important section of mathematics, which is coordinate geometry. So we will now start with our next section of mathematics, which is coordinate geometry. It is a simple and scoring section, so please pay attention to all the derivations and the problems that we take. First of all, what is a coordinate? So we have already studied in school. We have two axes. One is the x-axis, which is horizontal line, and another is y-axis, which is generally the vertical line. The x-axis and y-axis, they are both mutually perpendicular. Also, the point of intersection of x and y-axis is called origin 0, 0. So this 0, 0 here is the coordinate. X coordinate we write first, then we write y coordinate. So what is the meaning of x coordinate and y coordinate? To understand that, let us take one point. Let us say P, having coordinates x1, y1 in general. So x1 here refers to the x coordinate of point P. So x1 is the x coordinate of point P, and it is the distance of point P from y axis. So what is x coordinate? X coordinate of a point is the distance of that point from the y axis. Similarly, y1 is the y coordinate of point P. So it is the distance of the point P from x-axis. So what does x-coordinate refer to? X-coordinate refers to the distance of the point from the y-axis. So distance of point P from y-axis is x1, which is the x-coordinate of point P, which we generally write first. Then we have y1, which is the distance of the point from the x-axis. So y1 is the distance of point P from the x-axis, which we write after the x-coordinate. So for any point P, we first have the x-coordinate, then we write its y-coordinate. So this is the meaning of coordinate in 2D. We are here talking about 2 dimensions. Means we have x-axis and y-axis. It is a plane. We are not talking about 3D. In 3D, the definition changes, which we will later study in vectors chapter in 3 dimension. But in an xy plane, in a 2D plane, we have x coordinate, which is the distance from y axis, and y coordinate, which is the distance from x axis. So let us take some examples. So suppose this is our x axis, so this is our y axis. And suppose we have a point, let us say P, having, let us say, x coordinate as 2, y coordinate as 1. So how will we represent the point? First we will write the x coordinate, which is 2, then we will write the y coordinate, which is 1. Now, what does this x coordinate 2 refer to? X coordinate refers to the distance of the point from the y axis. So this distance of the point from the y-axis is 2, and y-coordinate refers to the distance of the point from the x-axis. So y-coordinate here is 1. So this is the meaning of coordinate. X-coordinate, distance from y-axis, y-coordinate, distance from x-axis. Now, after understanding the concept of x-coordinate and y-coordinate, let us move on to our next concept in coordinate geometry, which is slope. To understand the meaning of slope, let us take a situation. Suppose we have 2 hills, hill 1 and hill 2. Which of these hills has more slope? Of course, hill 1 is more steeper, so it will have more slope. Whereas hill 2 is less steeper, so it will have less slope. So slope refers to the steepness. Similarly, in case of a straight line, if I have a xy graph, and on this xy graph, if I have one line which is like this, let us say this is line number 1, and in another xy graph, we have another line which is, let us say, like this. So which of the two lines has more slope? Of course, line 1 will have more slope, line 2 will have less slope. Because slope refers to the angle with the horizontal. This angle, if I denote here by alpha, the angle made by the line with the positive x-axis, it is, let us say, alpha. And here, the angle made by line 2 with the positive x-axis is beta. So, more the angle, we can say more the slope. So, in this case, value of beta is less, value of alpha is more. So, we can say alpha is greater than beta. So, we can say the line will with more angle with the positive x-axis has more slope. So, this idea we borrow into mathematics, and we define slope for a straight line as tan of theta. So suppose we have x-axis and y-axis, and suppose we have any line making an angle theta with the positive x-axis. Then we define the slope of this line as tan theta. Slope is defined as tan of angle made by the line with positive x-axis. Let us now derive another formula for slope in terms of x coordinates and y coordinates. So, for that, let us first consider the x-axis and y-axis. Now, suppose we have a straight line which is making some angle theta with the positive x-axis. Then one formula for slope which we have already learned, it is tan theta, where theta is the angle made by the line with positive x-axis. On this line, let us consider 2 points. One is point P having coordinates x1, y1, and another is point Q having coordinate x2, y2. Now, let us find another formula for slope. If this angle is theta, and if I make a construction, if I draw a perpendicular from this point P, and suppose I draw a perpendicular from point Q as well, so we can say this perpendicular distance, this perpendicular from P is perpendicular to the x-axis, this perpendicular is perpendicular to the y-axis. And now I have a triangle, let us say PQR. This is the triangle. Now, if I extend this perpendicular to the x-axis and it meets, let us say, at point A, and if I extend this perpendicular on the y-axis and let us say it meets the y-axis on point B, then I can say PR is equal to PA minus RA. Now, what is the value of PA? PA value is y1 because distance from P to the x-axis is nothing but the y coordinate, which is y1. So I can say PR is equal to PA minus RA, where value of PA is y1 and value of RA will be equal to y2. Why? Because RA is equal to, let us say, QC, because they are opposite sides of a rectangle. So QC value is y2 because y2 is the y coordinate of point Q, which is nothing but the distance of point Q from the x-axis. QC is equal to RA, so RA value will be equal to y2. So we can say PR is equal to PA minus RA. PA value is Y1, RA value is Y2. So this is the value of PR. Let us call this equation number 1. Similarly, QR will be equal to BR minus BQ. What is the value of BR? So BR, in this case we can say the x coordinate of point R and point P, it will be same. So in this case we can say BR value is nothing but the x coordinate of point P, which is x1. So BR I can write as x1 minus BQ. We can say BQ. Here is the x coordinate of point Q. BQ is the x coordinate of point Q. So I can say BQ value is x2. So I can say QR value is x1 minus x2. I am marking this as equation 2. Now, if this angle I have marked as theta, the equation line, the angle which the line makes with positive x-axis, if it is theta, then I can say this angle is also theta by corresponding angles. So in this triangle which I have a triangle here which is right angle triangle where one angle is theta, this is point Q, this is point P, and this is point R. The value of PR we already found by geometry. It comes out to be Y1 minus Y2. Similarly, the value of QR we found it is x1 minus x2. Now, slope we know it is given by the formula tan theta. In this right angle triangle, if I take tan theta we know is opposite side upon adjacent side. In this case, opposite side is PR, which is Y1 minus Y2, and adjacent side is QR, which is x1 minus x2. So we can say in this triangle, tan theta is PR upon QR, which is Y1 minus Y2 upon x1 minus x2. So we have new formula for slope in terms of x and y coordinates. So we can say now we have two formulas for slope. Slope is equal to tan theta, where theta is the angle made by the line with positive x-axis, and another formula for slope in terms of x and y coordinate, it is y1 minus y2 upon x1 minus x2. Now we use the symbol for slope as small m. So we have slope which is denoted by the symbol small m. It is equal to the value of tan theta, where theta is the angle made by the line with positive x-axis, and that is equal to y1 minus y2 upon x1 minus x2. Sometimes we write it in another way, which is y2 minus y1 upon x1 x2 minus x1. Because these two are exactly same. If I reverse the numerator and denominator, it does not make any difference. So in this case, we can write slope as m, which is tan theta, which is y1 minus y2 upon x1 minus x2, or we can also write it as y2 minus y1 upon x2 minus x1. So this is the basic idea and the formula for slope. Because in this case, we have change in y coordinate. So we can denote the change in y coordinate by delta y symbol as well. Delta here refers to change. Delta y is change in y coordinate upon delta x, which is change in x coordinate. So the formula for slope is tan theta, where theta is the angle made by the line with the positive x-axis. It is also equal to y1 minus y2 upon x1 minus x2, which can also be written as y2 minus y1 upon x2 minus x1, because slope of PQ line is same as slope of QP line. It is also denoted by delta y, which is change in y coordinate, which is y2 minus y1 upon delta x, which is change in x coordinate, which is x2 minus x1. So this is the basic idea of slope of a line. If we have a line which is like this, let us say, so this is our line. In this case, the angle made by the line is acute angle. Then we can say slope of this line is tan theta and tan of acute angle is positive. For example, tan 45 is 1. So we can say tan of acute angle is positive. So slope of this line is positive. If we have another line like this, let us say we have another line which makes an obtuse angle with the positive x-axis. Then in this case we can say slope of this line which makes obtuse angle with the positive x-axis will come out to be negative. So if we have a line like this which makes obtuse angle with the positive x-axis, slope of that line will come out to be negative. Whereas if we have a line which makes an acute angle with the positive x-axis, slope of that line will come out to be positive. Similarly, if we talk about a line which is parallel to x-axis, so in this case we will have no angle with positive x-axis. So slope of this line will come out to be tan of 0, which is 0. And if we have a line which is parallel to y-axis, then slope of that line, it makes 90 degree with the positive x-axis. So slope of this line will come out to be tan of 90. Tan of 90 is undefined, we can say infinity. So these are the concepts which we should remember while understanding slope in coordinate geometry.